Hello and welcome. We'll be continuing on with a talk about the ideal gas law, or PVnRT. We're going to be looking at PVnRT combined with molar mass. So the ideal gas law, you hopefully remember, is PV equals nRT. Molar mass we've dealt with throughout the year, so we've seen it a bunch of times. When you look at the molar mass, you usually find out like the periodic table, and the units for that would be grams per mole. So if we look at that, grams, that's our mass, per mole. In PVnRT, that's N, the number of moles. So we could write that as capital M, molar mass, equals our mass over our moles, grams per mole. So those are the two things we're going to be using here as we examine these two together. So let's look at an example involving those. Let's say we want to find out what is the molar mass of a gas. You have 0.45 grams of gas occupy 3.45 liters when it's at 23 degrees Celsius and 2.50 ATM. And if you wanted to, if you feel like, oh, I think I got this down, you can go ahead and pause me and go ahead and see if you can figure it out on your own, or just think about it for a moment before we get started. It's always good for you. What we're looking for is our molar mass. We just said molar mass, grams per mole. So I'm just going to write that down there in the corner there. Whether you write it down on a paper or you're just thinking about it and keeping in mind that's what you're dealing with, you always want to have that in mind at least. Now, if I look at what we're given here, I do have a mass up there, 0.45 grams. I don't have a number of moles though. I don't have this N, which we would need to do our grams per mole. So I'm going to have to then figure out, using the other information, that this volume is given, this temperature is given, and this pressure is given. I'm going to use those then to figure out a number of moles, so I can do that in molar mass. And how we're going to figure out that number of moles using this information, that's our good friend PVnRT. So we do know a pressure, and it's in ATM, so we're good there. We know a volume, that's in liters. And we know R, and T, that's going to be our temperature. 23 degrees Celsius, we need that in Kelvin, so I'd add 273 to that, and that would give us 300. So if I plug those in, I know everything in that equation there except for N, and I can then divide both sides of my equation by the 0.0821 times 300, whether you divide by them all together at once by putting it in parentheses on your calculator, or if you multiply them together first and then divide by that number. That's up to you. Either way, you should do that as you're watching along here to make sure you know how to type in the calculator, not making stupid mistakes or whatever, and you compare. Know how to do all this stuff. You should get 0.0350 moles. Okay, so we got our moles. And like we said before, we have a mass. So if we're looking for our molar mass, mass over our number of moles, 0.45 grams was given to us over the 0.0350 moles that we just found. We're going to have 2 sig figs, because that 0.45 grams is 2 sig figs. And that would give us, when we calculate it out, 13 grams per mole. Not too bad, I don't think. So that's our ideal gas law and molar mass together.